Hi, we are here today to look at some problems that involve equilibrium, uh, particularly in JAMB 2007. So we are looking at JAMB questions that in 2007 that are related to equilibrium problems. Okay, once again, don't forget to visit my blog www.examsolve.blogspot.com. I am committed to loading it with stuffs that are vital for serious students. All right, you can't afford to miss the update that I will be loading into that blogs. Okay, now let's go straight to business and all of that. You have a question? A body of mass 4 kilogram resting on a smooth horizontal plane is simultaneously acted upon by two perpendicular forces, 6 Newton and 8 Newton. Calculate the acceleration of the motion. Calculate the acceleration of the motion. Okay, now let's see how to tackle that. All right, now we have to just find the resultant of that force. Once you get the resultant of the two forces, then we relate that to mass and then we get the acceleration. Simple. Okay, so we said the two forces acting on the body are perpendicular, so that brings us to this diagram. Okay, one is 8 Newton, the other one is 6 Newton, perpendicular to each other, so we find their resultant. Resultant R, let F be the resultant force. Okay, so that means F squared is 90 degrees. F squared is going to go 8 squared plus 6 squared. That's from Pythagoras theorem, right? So that means we have 64 plus 36, which is what, 100. Automatically F is going to be square root of 100, which is what, 10 Newton. So that's the force. Remember that acceleration is equal to force over mass, since force is equal to ma. So that means acceleration is going to be force, which is 10, over what is the mass? The mass is the mass of the body is 4 kilograms. Okay, so we have 10 over 4, which is what, 2.5 meter per second square. So that is the acceleration of the body. That is the acceleration of the body. Now, I hope you see how we applied Pythagoras theorem to solve this question. Okay, because they are perpendicular forces. These are perpendicular vectors. Pythagoras theorem is very important. Remember the Pythagoras theorem when we have a right angle triangle such that this is hypotenuse, this is opposite, and this is what, adjacent. We have that c squared is equal to a squared plus b squared. And when we are solving problem on equilibrium or resultant, we always use the hypotenuse to represent the resultant of the two forces, two perpendicular forces. Right. Let's check another question, because we have 3 questions in this year on equilibrium. The second question is we have that, look at what we have here. And, this is point O, this is a P, and this is Q, with Q with R. Then this is point R, and this point S. The question, the diagram above shows plank RS pivoted at its center of gravity O. Right, the center of gravity is O. Right, the question is, and is in equilibrium with the weights P and Q. Is in equilibrium with weight P and Q. If a weight 2P is added to P, the plank will be in equilibrium again by, it's a very good question. If a weight 2P is added to P, the plank will be in equilibrium again by, now look at the question. A, moving Q nearer to O. Okay, now if we move Q, we have increased p now to 3p. It has been tripled, right? Because we add 2p to it, so that becomes 3p. Okay. Now, the equilibrium would have been upset. Now, how are we going to attain equilibrium? Is it by Is it by moving Q nearer to O? If we move Q nearer to O, what happens? The distance decreases. And when the distance decreases, this one constitutes clockwise moment. This one constitutes what? Anti-clockwise moment, right? I know that moment is equal to what? Force times perpendicular distance. So now, this one we keep the distance constant, but we increase the force. So this moment has increased, so anti-clockwise moment has increased. Then clockwise moment also must what? Increase. And we increase the moment either by increasing the load, or that's increasing the load and keeping the distance constant, or increasing the distance and keeping the what? The load. Increasing the distance and keeping the load constant. I said again, moment can be increased either by increasing the load and keeping the distance constant, or increasing the constant and keeping the load constant, or by increasing both. By so doing, we increase the moment. So when we move Q nearer to O, we have reduced the distance and we are keeping the load constant. So that reduces what? The clockwise moment. So that makes clockwise moment go down. So A is wrong. B, moving P nearer to O. Right. When we move P nearer to O, right, of course, that means we have increased the load and reduced the distance. Of course, that is correct. So that we remove the excess load, because by reducing the distance and increasing the load by calculated amount, that means we have reduced the anticlockwise moment to excess. We have removed the excess in the anticlockwise moment to balance the clockwise moment. So B is the correct option. Now look at option C. Adding a weight Q to Q. No. Adding a weight Q to Q will make it 2Q. And when you make it 2Q, it will not balance. We are meant to add 2Q to Q. So as to be what? 3Q. So that option C is wrong. Then option D. Moving P further away from O. Moving P further away from O, we increase the anticlockwise moment further. So the correct option is option B. Moving P nearer to O. By so doing, the distance will reduce. So that means that reduction in the distance will compensate for the rise in the force. So that will ensure balance or ensure equilibrium in the system. Now, so that is the answer to that question. Now, the last question is number 9. They say, which of the below conditions must hold for a body acted upon by a system of 3 coplanar forces in equilibrium? 1, all the 3 forces must be concurrent. 2, the upward force is equal to the downward force. 3, the algebraic sum of the moment about any point must be 0. Are you getting that? Now, looking at that, the correct option is 1 and 3. 1, all the forces must be what? Concurrent. Then 3, the algebraic sum of the moment about any point must be 0. Now the question that the upward force is equal to the downward force, that one is for parallel forces. So the correct option is all the 3 forces must be concurrent, and 3, the algebraic sum of the moment about any point must be 0. So that is okay as per 2007 questions on equilibrium. Keep studying, okay, and success will come to you. I thank you for your time, and I also congratulate you for committing yourself to the cause of excellence. I wish you all the best as you pursue your dream.